In this video, we're going to look at the board game Can't Stop and see how it connects to combinatorics. In this video, I'm just going to kind of introduce the basic rules of this game, and in the future videos, we're going to talk about the interesting combinatorics questions that come out of it. So what is Can't Stop? Can't Stop is a game about trying to advance your little markers given by these these construction cones along a board. And how you're going to do that is you're going to roll 4 numbers. So let's say you roll 4 numbers. Let's say I roll 1, 3, 4, and 6. And what I'm going to do is I'm going to group those into 2 numbers. Maybe I'll do 1 and 4 over here, and then 3 and 6 over here. These total to 5 and 9, and what this would then let me do is move my 5 and 9 markers. And you just wash, rinse, and repeat. So you keep doing this process of rolling 4 dice, grouping it into 2 pairs, and then moving those markers, but there is a big exception. But you can only move 3 different numbers on a turn. If you roll dice and can't move a stop cone, or I've been calling it markers. If you can't move a marker, your turn ends, and you lose all your progress. So that's the big thing. It's a push your luck game where you want to try to move your markers as far as you can on a turn by keeping on rolling, but if you push your luck too far, you might roll something so that you can't move any of your markers, and then you lose everything you did this turn. So that gives us a big combinatorics question. Given 3 numbers, what is the chance that when I roll 4 dice, two of the dice will pair to one of those numbers? And this question is a lot harder than it seems. In fact, when I was in undergrad, one of my big projects that I did was not only analyzing the probability of this, but also doing some computer coding to simulate games of Can't Stop and study the strategies that way. As a result, I don't really see this game as a fun time, but more of an academic exercise that I went through in undergrad. But nevertheless, I'm going to mention it here, and we're gonna kind of dive into some of the combinatorics that went into that project that I did. So there you go. I'll see you in the next video.